are they? Mass, dashpot and spring. The spring is generally indicated by this symbol, but here instead of this symbol we have given resistance symbol, even though we have considered that as spring, So here we are having one mass element. Every node element is also considered as mass with zero weight. So what are the inputs and outputs here? Input to the system is force, right? Force. So Laplace transform of force is equal to f of s, and output of the system is displacement, and I am considering output as x2 of t. So Laplace transform of x2 of t is x2 of s. So the required transfer function is Laplace transform of output to the Laplace transform of input. So that is the equation we have to derive for the given translational system. So for that, first draw the free body diagram of mass. So here we are having one node where it is considered as mass, but that mass element is doesn't consisting of any value. That is why it is indicated as 0. And for this mass, here at this moment we are not applying any input force directly. There is no input force, and it is connected to two elements, to the K1 and K2. So because of those two elements, opposing force will be applied on this particular mass. So that opposing force is represented, that is F(K1), opposing force offered by spring K1, opposing force offered by spring K2, and the displacement of this particular mass is x1. So now this is called as free body diagram. So now write the force balance equations. Force balance equations, that is F(K1). F(K1) is equals to, here spring K1 is having one end fixed. Spring K1 is having one end fixed. So the force balance equation is K1 into corresponding displacement x1. Then the force balance equation of spring K2, which is having displacement at both ends. The K2 is having displacement at both ends. So the corresponding force balance equation K2 is equals to K2 into, we are writing these equations with respect to mass, that is this mass of x1. So x1 minus x2. Now apply that into Newton's second law. Sum of opposing forces is equals to sum of applied force. So here there is no applied force, so opposing forces is equals to 0. Substitute those here in this equation. K1 x1 plus K2 into x2 minus x1 minus x2 is equals to 0. Now apply Laplace transform to the above equation on both sides. Then that equation is written as x of s plus K2 into x1 of s minus x2 of s equals to 0. Take the common as x1 of s, will remain with K1 plus K2 minus x2 of s, common is will be made with only one element, that is K, is equals to 0. Let's say equation number 1. This equation is called as differential equation. In similar way, now we are going to write force balance equation for second mass element. So first, draw the free body diagram of mass element displacement of this is x2, displacement of N2 is x2, and here on N2 we are applying direct input force. So we are applying force, applied force is a property, and because of weight of the mass will opposes some force, that is opposite force offered by mass M2, F2, and it is connected to spring K1, only K2, so F2. So now write the force balance equations, force balance equations. Fm1 is equals to m1 into d square x2 by dt square, differential equation. Then Fk2, the spring K2 is having displacement